Algorithm example part B. Scan the transaction database to get the support S of each candidate K item set in the given set. Compare S with min sup and get a set of frequent K item sets. Using sets of F3, create C4. Since the support of this item set is less than 2, we will stop here and the final item set we will have is F3. With F3, we get the following item sets. For 1 equals set 1, 3, 5, subsets are 1, 3, 1, 5, 3, 5, 1, 3, 5. For 1 equals set 2, 3, 5, subsets are 2, 3, 2, 5, 3, 5, 2, 3, 5. We will create rules and apply them on item set F3. Now let's assume that the minimum confidence value is 60%. For every subset S of I, you output the rule. S is greater than IS means S recommends IS. If support I over support S is greater than or equal to min conf value. A priori algorithm rule selection. Based on the steps performed, a few rules have been selected and a few are rejected, so all the rules that are selected have a confidence value greater than 60%. For set 1, 3, 5, look at the rules. Rule 1. Set of 1, 3 greater than set of 1, 3, 5 minus set of 1, 3 means 1 and 3 greater than 5. Confidence equals support 1, 3, 5 over support 1, 3 equals 2 over 3 equals 66.66% greater than 60%. Hence, Rule 1 is selected. Rule 2, set 1, 5 greater than set 1, 3, 5 minus set 1, 5 means 1 and 5 greater than 3. Confidence equals support 1, 3, 5 over support 1, 5 equals 2 over 2 equals 100% greater than 60%. Rule 2 is selected. Rule 3, 3, 5 greater than set of 1, 3, 5 minus set of 3, 5 means 3 and 5 greater than 1. Confidence equals support 1, 3, 5 over support 3, 5 equals 2/3 equals 66.66% greater than 60%. Rule 3 is selected. Explain specifically why each and every rule is selected and rejected. Rule 4. Set of 1 greater than set of 1, 3, 5 minus set of 1 means 1 greater than 3 and 5. Confidence equals support 1, 3, 5 over support 1 equals 2/3 equals 66.66% greater than 60%. Rule 4 is selected. Rule 5. Set of 3 greater than set of 1, 3, 5 minus set of 3 means 3 greater than 1 and 5. Confidence equals support 1, 3, 5 over support 3 equals 2/4 equals 50% less than 60%. Rule 5 is rejected. Rule 6. Set of 5 greater than set of 1, 3, 5 minus set of 5 means 5 greater than 1 and 3. Confidence equals support 1, 3, 5 over support 5 equals 2/4 equals 50% less than 60%. Rule 6 is rejected. This is how you create rules in a priori algorithm, and the same steps can be implemented for the item set 2, 3, and 5. Demo User Movie Recommendation Model. Problem scenario. Consider the ratings dataset below containing the data on user ID, movie ID, rating, and timestamp. Each line of this file represents one rating of one movie by one user and has the following format: user ID, movie ID, rating, timestamp. Ratings are made on a 5-star scale with half-star increments. User ID represents the ID of the user, movie ID represents the ID of the movie, and timestamp represents the seconds from midnight Coordinated Universal Time, or UTC, of January 1, 1970. Here you are supposed to predict a user movie recommendation model. Let's import the required libraries. And the data set. Also add column names against the data set. Let's now print the resultant data frame. Since we are developing a user movie recommendation model, we must be aware of the number of users and the number of movies, so let us write the code for the same. Now we will split the data into training and testing sets, importing the train test split function from the sklearn.model selection module. First, create a zero matrix with dimensions as n_users and n_movies. Now that we have created train and test sets, we will populate the train and test metrics with ratings such that the user ID index minus movie ID index equals the given rating. We can now see that we have some movie ratings in the training set. We will do the same for the testing set. Now import the pairwise distances import from sklearn.metrics to create cosine similarity matrices for users and movies. Cosine similarity is a measure of similarity between two non-zero vectors of an inner product space that measures the cosine of the angle between them. The cosine is 0 degrees, is 1, and it is less than 1 for any angle in the interval 0 pi radians. Now we will go ahead with the predictions based on the fact that user-movie collaborative filtering's difference from mean rating is a better indicator than absolute rating. Calculate user prediction such that user prediction is the sum of the mean user rating and the dot product of user similarity and ratings difference divided by the absolute value of the user similarity. The matrix we received as output describes how those unrated movies will be rated by users based on their prior rating styles. Now that we have approximately generated ratings for all movies, let's quickly recap the steps we have covered. Import libraries and the data set. Identify total number of users and movies. Split the data into training and testing sets. Populate the train test matrices with the random ratings. Create cosine similarity matrices for users and movies. Perform predictions.